Hey, we're streaming now, David. I'll call you about it.
I'm gonna go in the other room. Will you guys talk so I can hear audio?
Yeah.
Check
Yeah.
the YouTube.
We'll talk.
David, did you get in your house?
As we're supposed to talk. How's everyone's day today?
Good, doing good.
So, right,
Thanks
how
for
about you?
sending me your stuff.
Pizza.
It's long.
Yeah, I already ordered pizza for the room here, so we got pizzas here and sodas and
I should go.
Candy.
Test project.
Is it good?
all kinds of good stuff.
I'll do this project.
I don't have the link for it.
And it's like 10
I gotta share the link.
So,
Yeah.
There it is.
Oh,
Rob, you can sit at the table.
I don't want to take anybody's spot.
Better not to have pizza.
is it raining from the Cascade?
Oh, I got you.
He's talking about the flooding that's gonna happen.
Oh, God.
Get your boat out kind of like, you know.
There's a delay. I'm posting this in the Teams.
Was it working?
Don't know.
My father-in-law passed away, so we're selling his house, so I was in the attic yesterday, and I looked up there in a little hole like that, up in the roof. So I called roofers, nobody can get out there till next week. And
You sent your otter?
Bucket, and sheets under it.
Your otter's in here.
Sheets of plastic.
Can you take it off? I didn't join it.
It automatically. I can't kick it out. I didn't start the meeting. I went to join the link, and then I was like, I don't know what the link is. So I shared it in the Teams chat. There's going to be a delay. I believe OBS should be streaming the screen I'm showing, which should be this, but it's not. We have no video on the stream right now. But there's like a delay. I can't remember how long the delay is.
Okay, Keegan's watching from the link, so it's David,
Mm-hmm.
John. Okay,
I got a call there. He was up here prepared to talk to him.
Keegan, is he?
Hello?
Why is the video playing? It's leaving.
Fireflies were up and running.
See, transition.
Never get my phone.
You got an otter and a firefly.
Yeah, someone's used fireflies though. I've got one.
Why is it not showing?
Is there something you need to do to
There we go. That's good.
Are we ready?
Sorry, guys.
only a minute late?
That's all right.
That's on time. This is serious.
Matt or Irish, you guys, or John, who's going to introduce our speaker here?
I guess I will. Hey, everyone, thank you for joining MCCOE on our monthly cyber talk. Today, we're going to be doing reverse engineering with Brandon Cain. Take it away, Brandon.
All right. So, real quick, intro. I'm an instructor at OTC. I've been in cybersecurity for a little bit. More my specialty is more networking, computer networking, and getting that set up. I've also got a little bit of a background in programming, so that's partly helps a lot in a lot of fields, but it helps a lot in the software reverse engineering as well, to be able to kind of follow the code and get a grasp and an understanding of what's what's happening. So I'm by no stretch of the imagination an expert in any kind of reverse engineering, and especially in software reverse engineering, but I've spent some time. And this is more of a explanation of my journey and what I've learned through this. So again, I think a little bit of that comes from just having a background in programming and being able to, like I said, follow along and get an idea of what's going on. So I'm going to be trying to. I'm not going to try. I'm going to reverse engineer as best I can, as much as I can, time allowed. We're going to take a look at WannaCry. So if anybody knows what WannaCry is, it was a famous ransomware worm in 2017, and it was broken. It was stopped for the most part by a kill switch. And I'm gonna step right into the debugger and try to explain as I go. I'm gonna explain some of the items that are in the debugger. I'm gonna explain what I'm thinking about, and we're just gonna go from there. So I've got a lot going on in a very short amount of time. So if anyone has any questions or wants to discuss anything further, we can do that afterwards. So what I start with is sometimes a debugger. So I like to use x64, but there's a 64-bit and a 32-bit version. That's usually for Windows. I also use Binary Ninja, and I'll explain why here shortly. And then Ghidra is another one that is really common. Ghidra is one that is used on, well, you can use it on Windows, but I like to use it for Linux because I've not found a good way to run a debug in Windows with Ghidra. I'm sure it's possible, but I just haven't found it yet. So I like to use x32 instead. So I'm just going to get right into this.
I've got notes. If you want to see who posts what in the notes.
So first things first, I don't have to go out of my way to find this. There's several repositories out there that have live malware. It's not illegal. You do need to be careful with it. It will get illegal. You will get into trouble if you just haphazardly run this stuff or also distribute it. That's going to be another thing. Probably should not use this for nefarious purposes. But I can use this to bring to myself and take a look at it. So I got this from Malware Bazaar. It was a little bit of a challenge to find the correct SHA hash. The only source that gave me the right one was Google. So it was a simple prompt. I had just a easy prompt. Find me the original WannaCry executable. And everyone else, ChatGPT, all the other AIs, they all had these other hashes, and it made no sense. But this one, I download this, and we got the full hash there. It's a password protected zip file. And anytime I go into here, I also got to turn off Windows AV, because as soon as I would extract that, it would eat it up. And if you're working on this and you do restart the operating system, I would probably zip it back up and password protect it, because Windows will turn itself back on, the Windows Defender. Another thing, obviously, I'm in a I'm in a VM, so this is part of doing this safely and not like executing this and putting it onto the network. I also have no network attached to my VM right now. So now, a couple things. Whenever you're looking at software, or whenever you create software, most of the time it's compiled. A lot of malware will probably be compiled software. So compiled means that I take the source code that a human can understand for the most part, and it turns it into assembly. So this main window right here, the CPU tab, is the assembly that gets generated. It gets compiled. And this compilation takes in the CPU architecture, and all of these functions, they're all called opcodes, correlate, and they do a very specific thing on that CPU based on the CPU architecture. So this is x86. There could be ARM64, there could be RISC-V, x64. For all intents and purposes, if you get the opportunity to do 32-bit, do that. It's much easier. So it's obviously not as easy to follow along, and I'm going to show you what I would use Binary Ninja for here in a second. So over here in the right side, these are all of the CPU registers. And the registers are temporary storage locations that are tied to the CPU. Sometimes they'll store data. Sometimes they will store memory addresses. But they are something that the CPU is closely tied to. It doesn't go to RAM, but memory is also something very closely tied. So again, these registers can have memory addresses, they can have data, and these are just things used by the CPU at the time of. So there's some documentation you could read, I guess you could say, but two ones that I pay attention to is EBP and ESP. These are for a stack. So a stack in any kind of any kind of software is a RAM storage, memory storage that is used locally within functions. Any functions, anything I do, this is I guess instanced. I would say this is a specific location on the RAM, on memory, that is used for local data, local variables within functions. So we'll see. I'll use this a lot to see how functions are being called. But this is one location where you can take a look and see what is being run, what is being stored in memory. And then over on the other side, we have just memory in general. So this is everything else in memory. Within x64, I got 5 different things just to go to different locations. And this would be more analogous to the heap. So whenever you run software, you have basically two locations of memory. You got the heap, which is global, and then you have the stack, which is more local stuff. So there's nothing really useful in here right now, but at some point we will see part of the process you can go through is to use the registers to go to these locations in memory and see what's being stored there. So part of the process that I'm going to use, that I go through with debugging, is to stop it. I can stop execution at certain points. and I want to see what's going to happen. I want to see what has happened, and I also want to see what is in memory at that point. So that's kind of the idea of debugging, is to set breakpoints, get an idea of what is happening, and then go from there. And then backing up, the whole idea of reverse engineering is to get an idea and to understand what malware is doing, what software is doing. This would probably, there's many different uses for this. There's various uses, to try and crack software or crack licensing or something along those lines. But I'm using this for a good purpose, to try to understand how malware would work. And part of my goal is to just gain that understanding. The process of debugging is to go line by line, which we can see this. So right now, this is sitting at what's called the entry point. Every single executable you run will have an entry point, and it will start there. And the process of debugging is where I can go through, and I need to be very careful and not do this because this will encrypt my computer. I can do what's called step into, and if I hit for instance, a call function, it would go to that next line. It would go to that function call, and I can step into that and go from there. Another crucial function is step over, which it would call this, and it would just step over it. It would go to the next line. So it would execute this and then go to the next line. There's a few others. Those are the two ones I use, and I use execute till return. So right now I'm sitting at the top, the very first function that's ever called, and if I execute it till return, it would execute everything and it would encrypt my computer. So I don't want to do that. But one of the things I can do is step through this, and it's just going to go line by line. So what it's doing right now is just setting up the PE, the portable executable, the Windows executable. And at some point, I will show you in Binary Ninja that it's going to get to a certain function call. So let's go take a look at that. Binary Ninja. So one of the things Binary Ninja does is give me human readable code. Now, obviously, this is not the source code. Okay, no one's going to say to use variable names such as ESI and var 78. That'd be pretty crucial. I would hope no one does that. But what this is doing is interpreting the raw assembly code, which is not really human readable, and doing its best to give me C code. So it's called pseudo C, but this is basically C syntax to help me understand what's happening. And I use this to get a broad overview of all of the functions and how data is, how the program is flowing. So I'm not too concerned about a lot of this. Again, a lot of this is setting up the executable, and one of the other things I'm going to look for are these API calls. So these are functions that are built into Windows, that are abstracted from Windows, I guess you could say, or built into Windows. And my first goal, one of my top goals, is to use those and find out what this software is doing. So I can't see a whole lot into these. I think I can maybe no, I can't. But I know that the first thing I was going to do is go into this function here. So another thing as well, none of this code is what the source code looks like. It's nothing what the developer created. These are arbitrary functions that the compiler, Binary Ninja, has created. So I can go rename these. In fact, I could do that here. And I'm going to say that this is probably the main. And one other thing I can do with this debugger is step through things, go through it slowly, and figure out where it goes. Seriously. All right. So we call this the main function. Now, one of the things that we know, that I know about WannaCry, and I'll also say another thing. So my goal, my intention is to learn. I probably am not skilled enough to interpret all of this on my own, but one of the things I did was research WannaCry and figure out what it did, what it does, and then I went back and found those sections in this code so I can understand what's happening. So if you recall, there is the very first WannaCry had a kill switch. And this is, again, Windows APIs that is opening this URL, and if it can reach it, then it stops. It closes the handle, returns 0, and stops. So that was the very first kill switch of WannaCry, and it did that, I think, because that was a way to test for a sandbox environment. So if that DNS query succeeded of this random domain name, that's one of the things in a sandbox, in a network simulation, is that it would answer for everything. So if that was the case, if it succeeded, well, chances are we're in a sandbox, so it stopped. Otherwise, it goes on to our next function. So I'm going to step through this. One of the things that it does is there it is. I can see in here, and again, these are some basic C functions. So one of the things that this does is creates a new file called tasksketch.exe. And I know, but we can also ascertain this, that it is going to move. It will move that. Creates that. It will move. Sorry, it'll move the original to this random executable, and hides the original task sketch, and drops itself in there. So I could, in theory, I can go through this and execute this and stop it here after it's created that. But one of the other tools I'm going to use is one of the other things in here as well, is these functions up here are to load any kind of resource, any kind of binary, any kind of executable, anything that is packed inside of this original file. And I get a hunch that it's loading that and probably writing that to task sketch. So I can also use a tool to extract that myself. I'm going to do that.
What tool are you using?
PE Bear.
Bear.
So PE Bear is something I found along my journey trying to break into WannaCry. There's a few other tools that can do this as well, but we'll take a look at this. So I'll give it my original file, and I'm going to go to resources, and I'm not looking at much in here. I just want to extract all of the resources that are in this executable. And I'll put this here. So I know, and I will tell you that this is the new file, and I can also, so I can bring this into Binary Ninja again. This is the encrypting payload. This is one of the payloads. The original executable also starts a service and creates a service. And I don't think I'll have the time to go into the worm component, but the worm component is in here. But for the record, we can go back here. And one of the other things that this does is say if there's no parameters passed to this executable, then it installs itself. If there are parameters, then it goes down here and starts this. So I had a little bit of trouble trying to find and figure this out, but I finally did. This function right here is what it's going to call. And somewhere in here, I believe it does this. So this is the service that it starts. So WannaCry creates its own service, and it would go into here, and then based on these built-in these API functions, I can see that it creates some threads. So an important word on these APIs. Again, these are usually DLLs. In Linux, they're going to be just libraries. But these are used by any software, malware alike, to interact with the operating system, to interact with the kernel, to interact with the hardware. So any malware, any software, in order to interact with the hardware, the network, the disk, file I/O, it has to go through that. So with that knowledge, I know that I can stop on a lot of these calls. I can set a breakpoint on these calls and stop it from doing anything and see what it's doing to the operating system based on those calls. So these are named accordingly because these are API functions that are built into Windows, and I can see what's going on here. So you can also go and you can look up these on the internet, on Microsoft, and you will see what all of these correspond to. And I know that these two functions right here are what it would call to start the thread. And it goes down a little bit, but at some point you will see that it will start calling some socket connects. So this is the worm component of WannaCry. I know Again, this looks unreadable. It kind of is, but I at least want to identify where and that it does, in fact, interact with the network, and it will start. This is the area where it would start propagating itself. So I'm going to go back. I'm going to take a look at the encryptor. So this was the resource that it extracted. And I can easily open this up. It is recognized as a PE and a lot of the same signature as before. So this is my first function that I go into. And now I see a few things in here. One thing is a hard-coded password. So this is actually a password that is used to extract the, I guess, next step of the payload. And contained in here are some Tor addresses, onion addresses. This also contains another piece of executable code that goes through and starts encrypting our data. So I'm going to run through it and get that out of there real quick. And I'm going to use this. I know that this is a zip somewhere in here. I believe it's here. So again, I look at this and I see something that's similar to unzip. So this tells me, and I have a pretty good idea that this is going to be a zip directory. So again, I can bring this into PE Bear. Do the same thing. And this is my next resource. So I know this is a zip. I can simply go in here and name it as such. And I can go extract it with 7-zip because Windows won't open it. And I'll go back. I'll go back here. And there's all of the payload that it would originally dump. So this code goes through and extracts all of that. So there's C, WannaCry, whatever you want to call that. There's T, and some of these files I think contain a public key. Again, this T file here contains the next step, the next payload that would do the encryption. So I'm sure there's a way, but it is that is not a PE. That is not an executable. So I can't just haphazardly open it in Binary Ninja. I'm sure there's a way to identify where the executable code is, but I can't do that. So what I'm going to do is open our next payload in x64, x32. And I know it was that. Now, Windows obviously doesn't like this, but it's not going to do anything. It's not going to kill it. That's fine. So one of the things I can do is turn off something. Now I can use Binary Ninja to line up where this stuff gets called, but I know that this is here, and if I scroll through this, I will see a lot of the same things, just not as neatly organized. So we saw this, we saw the password there. Okay, this is doing all the same stuff. And at some point, okay, the next thing that this does gets all the way down here. And one of the things I'm looking at here is this H global. This is actually a variable that's used to carve out a space in memory in the RAM. And just a quick hunch, so there's some other things in here. I think there's probably, yeah. So there's some allocation, there's alloc, and some other functions in here that tell me that it is loading this executable code, this binary, into memory, and it's looking for this function called task start, and then it executes it here at this EAX14. So I can take these addresses right here. These are memory addresses. Not memory. These are addresses in the executable. So I can go to that same thing in, which I'm already there, but same address here. So what I'm going to do, set a breakpoint there, and it's going to stop before it calls that, because after it calls that, it's going to go into the payload and blow away my computer. So something to bear in mind, I don't want to just go in here and haphazardly call this. The software can mitigate my breakpoints. It can get rid of this particular breakpoint. It can also detect if a debugger is running. And if it does that, it could do some other things and go ahead and execute itself. I got to be aware of that. But nothing in here. So this is going to do all of this. It's going to unpack everything, and it's going to load it into memory at this point. So I'm hitting F9 point of entry. My breakpoints are still here. And it stops there. Now, this is where I'm going to use my registry. So this call is used universally to start a function, to call a function. And it is calling this function. It's found where task start is, and it's located here, and it's going to call and start and jump to this memory address. So I want to get that out of memory. So I can follow that memory map, and we don't need to be too concerned with all of this. All I want is this right here. So I can dump this. Again, to resources. And now I can bring that back into Binary Ninja again. It's this bin file. Okay. So now in here, these are all the functions. Now I have my task start in here. So this is the next step. There's a series of 3 different areas that it will extract the code. So I don't have a whole lot of time, so I'm going to get straight to the good stuff. You can see there creates some threads in here. Again, these correlate directly to what's being called in Windows. And my goal right now, what I want to identify is where it encrypts this data. So again, I'm going to go ahead and I'm going to let this go through, but I'm going to set breakpoints. So this is one of the reasons why I like to use x64. I don't know why. I don't know if it's something I haven't found yet, but I can't set breakpoints on these API calls in Binary Ninja. So in Next64, I can go to where these are going to be called. So we're looking at ransomware. I want to find when it reads a file, when it creates a file, when it writes a file. Makes sense, right? So I'm hitting F2. These are all shortcuts that I've memorized by now, but create file, append and write, read file, and write file. So anytime this malware is going to call this now, it's going to stop before it calls that. And I can stop it and I can prevent it from happening. Or again, see that it's going to happen. So whenever I do this, breakpoints are set. We'll let this go through. And it's stopping on create file. So I'm not too concerned about this. I know that this is a file that's used for the public key. I want to see whenever it starts interacting with my file system. So I'm going to go through this, and at some point, let's see, do I have that on here? No, I don't. I need to give it something to target because I don't want it to. I know that it does this correctly, and I don't want it to go anywhere else. Okay, I'm giving it something to look into. Okay, now it's getting, so what I'm looking at is on the stack. So if I were to, well, I'll actually go into read file here in a second, but I can tell this is a variable that would be passed into this create file function, and it's going through and trying to find files. Right now, I think this is just this looks like just a directory, and it gets into my A folder, and now it's gonna catch my text file that I just made. So I'm gonna go through read file. So real quick, if I go into Windows, if I go to Microsoft, it's purple. I've been here a number of times. You can see the variables that go into this right here. So there's a file handle, the buffer, and this is where the data is going to be stored, and the number of bytes to read. So these correlate really nicely to 1, 2, 3. So this is the memory location for the file handle. This is the memory location where it's going to be stored, and it's going to be storing 8 bytes. So I'm going to get through this, but I will tell you that this is reading the first 8 bytes of my file, my functions text file, to look for WannaCry, which is a piece of text that it writes in all the files to check if it's encrypted already. So I can go through this. And I'm going to get to my, that's it. Maybe it is. I don't think it is. So now I can go through this, and I'm sitting in this particular read function, and I can go ahead and execute this until return. And I went to this memory location in my dump, and I see all of the text that is in my file. Okay, so that's going to be the first that's going to be the first thing it needs to do is read the file so that it can encrypt it, right? Makes sense. So now what I want to do is I know that it's going to have to use that data, right? Now I can set a breakpoint on this memory location. So anytime this malware references this location, it's going to stop. So I will do breakpoint, any memory access. And again, anytime the software is going to need to go here to just to read this and data and encrypt it. So I will go through here. I know that this is not anything I need to be concerned about. It hit the memory breakpoint that I just set. Go. All right, so now this is the next area that it starts to read from that memory location. And one of the things that is really cool is I can start to step through these line by line. And one of the things that it's doing is moving this to this location, moving this text to this location, step by step. And this is also going to iterate 16 times. So I know that this value right here is comparing EDI to ECX. We're at 3. This is 16 in hex. And it's going to iterate 16 times and read 16 bytes of data into memory. Where did this go? Oh, there it is. Now, my last goal, again, time flies. So what I'm wanting to find is where this is at in the big picture. So this is where it's going to start doing the encrypting. I can also show you, I can set a breakpoint after it reads the 16 bytes. Oh, I've got the breakpoint set in memory still. That's why. And if I go through this, at some point, you're going to see this data down here go bye-bye. It's going to get encrypted. And my thread is bugging me now. Go away. And there it went. So I was looking in memory, and I can see that data gets encrypted. So now my last goal is I want to find where this is at. So 6A0F. No, G. So this is where I'm at right now. And what I would do is start stepping backwards through all of these functions. So this function is called from these locations. So I can go here. I will, again, my goal right now is just to find where it's doing the encryption. I go back up. I see where it's called. And as you're going through this, you can also name these functions accordingly to what you perceive they're doing. So here's a switch. Again, keep going. Keep going. Hope I didn't hit a loop. I shouldn't have hit a loop. Is it this? Yeah, we're making progress. So it's a ways down in here. All right, here's my original task start. So you can see right here, this function is where it would break into doing the encryption. So a few of the things in here, some of the other things that it does would go kill SQL services, and it looks like after it would complete, it would also call the one decryptor, which is the lovely window that would show and say that you've been encrypted. Okay. So that was a quick 50 minutes for me. I don't know about you guys.
Nice to feel. What's the IDE you're using here?
Huh?
What's the IDE?
Barely getting started.
IDE?
Yeah.
This is Binary Ninja.
Okay, it's binary ninja. Okay.
That's not actual source code. That's just what it's decompiled.
Brandon, I got a question. I'm curious. I noticed that when you were doing certain parts, that it would trigger the defender. Do you know what was actually flagging that or causing that to happen?
Something in the memory, I would assume,
Okay,
and things in the file system.
cool. You can kind of like understand how the antiviruses and stuff like that work through this process. You can kind of see like what flags they're triggering on and stuff like that. It's kind of interesting.
So yeah, just real quick again, I'm looking for things that I can recognize, like taskkill.exe. This is a hard coded string that goes in here and does what it says. And again, looking for other API calls, set folder path, some C functions, and through that, I can begin to understand what is happening here.
Going through this, what improvements would you make to want to cry? If you had to rewrite it.
I would put in anti-debugging stuff in here.
It's got a hard coded, password.
That would help a lot. But again, I could still get around that. I would have to execute this and stop it whenever it hits that area. So anti-debugging, again, there is a Windows API, Windows, the kernel, Linux, Windows, doesn't matter. They all know if there is a debugger attached to a process, and the software, the malware, could call that and detect that and do certain things if it detects that. But if that's the case, it'd be a simple, like, if debugger is present, then stop or do something, kind of like what the kill switch was. And I would have to either patch that and make it to where it doesn't jump over that, or stop there and get it to change that execution instead.
Very cool.
So I know this is probably kind of like just a fire hose, but I wanted to do something live and demonstrate, and there's a lot to do and want to cry.
Yeah, that's really cool.
So if someone is getting started, what steps should they take if they're getting started?
I would either write your own code, C code, compile it, and bring it into a decompiler, into a debugger, or go to this little site. So these are just little simple executables that people write for you to go crack and find a flag, or a lot of times it's just a simple you succeeded or you got in or a success string that gets printed. So go here, bring these into a debugger, and again, just go line by line. Go line by line, just like I do here with step into. Again, step into would, like this call right here, it would step into this function and then start there. So you just go line by line, and then that's, I don't know if anyone's ever seen the movie Arrival, where she starts reading the language and then she can tell time. She can see in the future. It's like if you start stepping through assembly, you can start to understand it. Maybe not.
I've never seen it.
I haven't seen that. I have to check it out.
But seriously though, you bring something in here and you just step line by line and start to see what everything does.
It does. Executes, yeah. Very cool. Yeah.
And this assembly is the lowest level language you can get to essentially.
Are you guys teaching assembly code?
No, this is all me.
Yeah, I was gonna say I did assembly years ago, punch cards. And all that.
I don't want to do it. I want to get into this far enough so I can just understand it. That's it. I do not ever want to write assembly code.
Yeah,
The compiler takes care of so much stuff.
yeah.
I don't want to do that.
Oh, very good. I heard a question, so like on the line here. Did somebody start to say something? David, you still there?
I've got some.
Miller, yeah, David's there. He's muted.
Now,
No.
you guys teach this at OTC, Reverse Code Engineering?
No.
I wonder if anybody knew that universities teach it. Yeah.
No,
It's
but
a
they
fun-
should.
It's a fun topic.
Yeah.
Yeah.
It is.
There's many things I could not step into and explain, like the science behind encryption. Oh, crap. Let me show you this. What was that last address I went to? Is this still in here? One other thing as well, I know that this is encryption because I see a bunch of shifts, bitwise shifts, and XOR. So there's a shift. And this is the nitty gritty of encryption. Like this is what you would see on the CPU. I don't want to get into it.
Yeah.
I don't understand it. There's an XOR operation there as well. These are key indicators of encryption. So I know that this is where it does the encrypting.
Cool. Yeah, play around with it.
Be careful. Probably, I'll be honest, I have let this run once or twice because I was not paying attention and blew away my computer. That's why I want a VM. I'll disclose that. So be careful.
It can happen.
So anyone attempting this should be let through the
Yes.
Oh, yeah.
Or
Oh, yeah.
prepared to lose everything at least. Nice.
Any other questions on Teams?
Yeah, does everybody listening have any questions?
And then I guess it goes without saying to make sure that when you do it through a VM that you have no network connection.
Yes.
Yes. I have no network connection on this VM. It's safe. It can't propagate. We're good.
Are you just using a clean Windows VM for your?
Yeah.
Using something like Flare.
Huh?
Flare VM.
No. I just built a straight Windows VM and put all my debug tools on here, all my tools and stuff, and then made a snapshot.
Cool. Yeah. Great job.
Awesome. Gonna go ahead and close the stream.